Solving exponential and logarithmic equations. So this is example 5. This is the last example, solving exponential inequalities. So let's look at what it means to solve an inequality. So an exponential property of inequality says if b is a positive real number greater than 1, then b to the x is greater than b to the y, if and only if x is greater than y. And b to the x is less than b to the y if and only if x is less than y. So this also holds true for less than or equal to and greater than or equal to. So remember, if it's exponential, the base has to be greater than 1 because 1 squared is 1, 1 cubed is 1, 1 to the fourth is 1. If the base is 1, it's not going to be exponential. It's just going to be 1. So it has to be a positive real number greater than 1. So that's talking about your base. All right, let's look at example 5, A part. We have 2 raised to the 2x is greater than 2 raised to the x plus 1. So just like in the previous examples, we can rewrite this. So we can rewrite this using the properties. So it has the same base. So we can drop the base and just solve using the exponents. So we're going to have 2x greater than x plus 1. So very similar to solving equations. Now we're just solving an inequality. So subtract x. So we're going to have 2x minus x is greater than 1. So for A part, the solution is going to be x greater than 1. So all x is greater than 1. All right, B part says 3 to the x is less than 20. All right, so since I can't write 20 as a number 3 to some power, I can rewrite it as 4 times 5 or 2 times 10, but there's no base of 3 that I can rewrite it to. So using the properties of inequalities, I have to have the same base. So since I can't use the same base, I'm going to have to rewrite the exponential equation as a logarithmic equation. So remember, whatever this base is, that's what we want to use for our log base. Just like with equations, inequality is going to work very similar. So let's write this as log base 3 of 3 to the x power, and that's going to be less than log base 3 of 20. Okay, so we just added the logarithm to both sides of the inequality. Why did we do that? Log base 3 of 3 is 1, so that drops, and that's going to give me x is less than log base 3 of 20. And hopefully you remember from previous lessons that you can type this in your calculator. You can either use the change of base formula and do log of 20 divided by log of 3, or you can just use the button I showed you and type in using the log base button. So if you go to math, arrow up to log base 3 of 20, and that gives you your answer here. So it's going to be approximately 2.727. So x is about 2.727. And just kind of a reminder, you don't want to forget how to use change of base. If you use this button here, it's base 10, but you can do log of 20 divided by log of 3, and that's going to give you the same answer. So don't forget how to use the change of base formula using your calculator, because that is one of the standards for Algebra 2. All right, example 5C. We have 5 raised to the x plus 1 is less than or equal to 50. All right, so I can write 50 as 5 times 10, but I can't write it as 50 as 5 to some power. So I cannot rewrite this with the same base. So once again, I'm going to rewrite this as a logarithm, and I'm going to use log base 5 so that this will the left side here, the base will cancel. So rewrite this as a logarithm. So I'm going to have log base 5 of 5 to the x plus 1. And that's going to be less than or equal to log base 5 of 50. All right, log base 5 of 5 equals 1. That cancels and leaves me x plus 1 less than or equal to log base 5 of 50. All right, now I'm not solving for x plus 1. I want to solve for just x. So I can subtract 1 from both sides. And then I can type that in my calculator. So let's see what I get. So let's go to my calculator. I'm going to do math. I'm going to arrow up to log base. I'm going to do log base 5 of 50. And then I'm going to subtract 1 from that. And that's going to give me approximately 1.431. All right, so x is approximately, or the solution is approximately x less than or equal to 1.431. So let's rewrite this. I'll put an approximate answer here, but it's still going to be my inequality sign, x less than or equal to. And this one probably should be that as well. So let's change that. I'm used to doing the equations more than the inequalities. So make sure you've got the inequality symbol there. That should be a 1. And that's it for solving exponential inequalities. Again, it's very similar to equations. You just have to make sure that these properties hold true. If you have any questions, please let me know.